Exercise 1.1 of Class 12 NCERT book. Questions on reflexive, symmetric, transitive, and equivalence relations. Check whether the relations are defined in the set 1, 2, 3, 4, 5, 6 as R is equal to ordered pairs A, comma B such that B is equal to A plus 1 is reflexive, symmetric, or transitive. The given set here is a limited set, very few elements 1, 2, 3, 4, 5, 6. A relation is defined from set A to set A. A relation defined in the set means both domain and codomain are same set. And any relation is subset of A cross A. A cross A is set of all possible pairs that can be made using the elements of set A. From A cross A, some pairs can be included to make this subset, to make this relation. We will be picking only those A, B pair in such a way that the second element B is equal to first element A plus 1. Only such pairs. Let's see which all ordered pairs can be included in this relation. 1, 2. A is 1, B is 2. Yes, 1 plus 1 is 2, correct. 1, 2 will satisfy the condition B is equal to A plus 1. So 1, 2 will be included in A, B in this relation, given relation. 2, 3, 3, 4, 4, 5, 5, 6 and no other pair. All these pairs now can be written in the roster form just by listing them down. The relation is now written in the roster form. R is the relation defined from set of natural numbers to natural numbers, not all natural numbers. The given set, let's call it A, set A. So set A to set A. And these are the ordered pairs that can be included according to this condition. Now we need to check whether this relation is reflexive. What is reflexive relation? A relation in set A is called reflexive relation if the ordered pairs of the form A, A belong to R for all A's, all elements of the set A. Let's see. The elements of the form A, A means both coordinates are same. That means 1, 1, 2, 2, 3, 3, 4, 4, etc. As we see here, 1, 1 pair is not in the relation. Why? Because the ordered pair 1, 1. If you place A as 1 and B as 1, this equation is not true. 1 plus 1 is not equal to 1. So, the ordered pair 1, 1 is not following this condition. We can just highlight any such element which should have been there in the relation to call it reflexive, but fails to be present in the relation. Highlight that. I am writing 2, 2 does not belong to R. I have a reason. 2, 2 does not belong to this relation because placing A as 2 and B as 2 in this equation, it's not coming true. 2 is equal to 2 plus 1 is not true. So this goes as a counter example. An example that goes against the definition. A element should have been there to call it reflexive relation. We find such elements are not there. So this relation is not reflexive. Let's see if it is symmetric relation. A relation in set A is called symmetric relation if A, B pair belong to R implies B, A pair also belong to R. So let's go by checking one pair A, B. Any pair you could take. I am taking 2, 3, which is present in the relation. Yes, 2, 3 is present in the relation. But can we find a 3, 2 in the relation? I have not written that to 3, 2. Why? Because first element A has 3 and second element has 2. 3, 2 is not satisfying this given condition. as 3 plus 1 is not 2. So 2, 3 belongs to R, but 3, 2 does not belong to R. This numerical example acts as a counter example. An example which goes against the definition. So we say this relation is not a symmetric relation. Now we need to check whether it is a transitive relation. For a relation to be called a transitive relation, whenever the pairs of the form ABBC are there in the relation, it should imply that the pair AC also will belong to the relation. Let's go and see whether we have such pairs here. ABBC, ABBC. What's special with ABBC? Here B is same element in both of them. Second element here and first element in the second one are same. B is same. ABBC. So let's take some pair from here in that form. I'm taking 1, 2, 2, 3. 1, 2, 2, 3. Yes, B is taken same. B here same. 1, 2, 2, 3. 1, 2, 2, 3 are in the relation. But can we find a 1, 3? When 1, 2, 2, 3 are there, 1, 3 should have been there to call it a transitive relation, because the definition says whenever A, B, B, C are there in the relation, the pair AC should also be present in the relation. We can't find 1, 3 in the relation. 1, 3 will not satisfy this condition. A equal to 1, B equal to 3. How is it possible? 1 plus 1 cannot be 3. So 1, 2 and 2, 3 are there in the relation, but 1, 3 is not in the relation. Hence, this relation is not a transitive relation. A relation which is reflexive, symmetric and transitive is called an equivalence relation. Of course, this given example relation is none of them. So, it fails to be an equivalence relation also. Here, note one thing. These numerical examples go against the definition. Whenever we want to show one definition is not applicable for an example, we can go highlight an example which is called counter example. But if we want to show this definition is applicable to the example, we cannot simply show few numerical examples. That time we will have to show it by using general elements, by highlighting the conditions, not examples. Examples are used, numerical examples are used only to show the statements are not valid. To show they are valid, never use numerical examples.